So question to the audience, who has ever deployed the sys benchmark on Kubernetes or on Docker? All right, here's the person who authored or co-authored them. So I don't like to use the word luminary, but for me, Rory McCune is exactly that in the security field, and I've been looking forward to this talk a lot. And I don't think you need that much of an introduction. I mean, you are one of the go-to people when it's about red teaming, the blogs of the research you did. And well, without much further ado, I want to welcome you.
Awesome.
Thank you for coming to Vienna and enjoy the talk. Fortifying Kubernetes. Rory.
Woo. Good afternoon, everyone. Thank you so much for that introduction. Yes, what I wanted to talk about today is about fortifying Kubernetes, some of the things you might want to think about when you're deploying Kubernetes, some of the choices you have to make, because security is all about trade-offs and choices, and some ideas about specific things you could think about when you're either deploying new clusters or you are changing your platform or you're thinking what you could do next. Before I get started, very quick about me. So I have been in security for a while. I don't put the number of years there anymore because it's a bit too many. I've been in container security for about 8 or 9 years. I'm a senior security advocate for Datadog. So if you haven't heard of Datadog, we are an observability and security company. And yes, as mentioned, I am one of the authors of the CIS benchmarks for Docker and Kubernetes. So if you've ever used a CSPM product, pretty much any CSPM product, cloud security, posture management, you probably inadvertently use the CIS benchmarks. And if anyone's looking to sort of say horrible things about them, actually please do tell me, because we always like to try and fix them. And I know they're not perfect. So if anyone's got any ideas or wants to like harangue me about CIS benchmarks after the talk, we can do that. I also do a couple of things in the Kubernetes community. I participate in Kubernetes SIG security. So if you're interested in security at all, and maybe this talk fires an interest in you, or you're already interested, then we meet every other week. A very friendly group. You can just come along and participate. I'm also very proud to be a member of the only, I think, unofficial Kubernetes SIG to have ever keynoted KubeCon, which is SIG Honk, which is what the Goose logo is all about. And if you've ever seen the Goose logo in the Kubernetes security docs, that's kind of where it comes from. It comes from a thing called the Untitled Goose Game. So that's that. As you might have guessed by my accent, I'm not a local, so unfortunately I'm not from Vienna. I'm from here. This is Loch Goil Head in the West Scottish Highlands, just north of Glasgow. As you can see, I did not take this picture recently because it does not look this nice. But when it's nice, it's very nice. Please do come up to the Highlands. Anyway, let's get on with the talk. So the first thing I wanted to talk about was, is it secure? I've been in security a long time, and people will very often ask me the question, is this secure? Is this configuration secure? Is this product secure? And I pretty much always answer with, it depends. This is not an answer that most people want to hear. They don't want to hear it depends. They want to hear yes or no. But a lot of what I wanted to talk about today is why it depends. Why does it depend? Why can't I just say, yes, this is secure, or no, this is insecure? And the answer is there's lots of different factors that we need to consider when we're thinking about how we implement security. And I want to talk about some of those and talk about why it depends. But it is very important. It does depend. If your security people say to you it depends, honestly, they're not just being obscure or trying not to do their job. There are good reasons. But obviously, we would like to say that we can do everything in security. We'd like to say we can always do all of the security things, but we can't. We might hope that we had resources that look like this. We have a whole team of people who can spring into action anytime there's an incident, anytime there's an unpatched container image, anytime a CSPM product says we've got a misconfiguration. And it would be great if it was, but that is not how resources work. We don't have enough resources for everything. I'm sure there's anyone in the room who would say they have always been able to have as many resources they want for testing, for performance monitoring, for security. We don't have that. Our resources might look a bit more like this. We might have one person. We might have a small section of one person. Right? You might have been told you're now DevSecOps. Used to be DevOps, now you're DevSecOps, and what that means is you have to do security as well. We probably don't have time for that. So a very important thing to think about when you want to consider what security thing you're going to work on and which of the many you could do you're going to do is, do I have enough resources for this? What do I have resources to do? Don't take on a huge project that might take all of these people if you've only got this person. So how do we choose, right? All these things we can do. We've only got a certain number of resources. How do we pick? Well, with Kubernetes, one of the main things about Kubernetes is it's so incredibly flexible, and one of the reasons why you can't say it's secure or insecure. How am I using Kubernetes is a massive question. There's lots of different ways to do it. We could do it like this. We could have a super simple cluster. We've got a single team, a single application set up as some microservices with a single namespace. And they're managing the cluster themselves, and they're also managing the application. If this is your environment, you have a nice simple setup. You don't have a lot to do, and we probably can cover more ground. But that's not how a lot of people deploy Kubernetes, obviously. They might deploy it like this. We've got multiple teams. Each has their own applications, each in their own namespaces. It might not be 2, it could be 10, 50, 100, 1,000 even in one cluster. We probably then have an SRE team who manage the actual underlying infrastructure. They manage the nodes, the cluster. So they have different needs at this point. So we obviously now see there's different things we want to do already. Or maybe we have this, right? We want to really make good use of those shared nodes. I want to keep my cloud bill down as much as possible, so I'm going to put as many apps as I can. I'm going to put development, I'm going to put test, I'm going to put production all in the same cluster. And I have seen a lot of clusters deployed like this. So now we have more concerns. We've got non-production code. We've got application owners who need more access to the cluster to troubleshoot development environments. Again, we've got more things to think about. So this is another bit of it depends. Which of these are you doing? Or we could be doing what I always call the ultimate Kubernetes security challenge, multi-tenancy. We are going to, in some way, take code from customers, people we don't trust, and we are going to execute code in that code inside our cluster. There was actually a good example in the keynote at the start, was that example of there's a button in the web interface that says run JavaScript, and you could write any JavaScript you want. If you had the Kubernetes cluster behind that, you're doing multi-tenancy. You may not know you are, but you are, because you're saying to people, hey, take this random code and execute it in a pod in my cluster. Now we've got a whole lot of concerns. You might even be doing what I think is absolutely the ultimate thing to try and do in Kubernetes security, and let customers have kubectl access, namespace as a service. I have seen it offered. I think it must be really difficult. But now, obviously, here's the it depends, because those two, the first example, the last example, totally different. Not the same needs. Okay, so I've said there's different ways you can run it. And I've said that you've got different levels of resources. How else can you think about what security should I put in place? Who's attacking me? Who is going to attack me? Because it changes depending on what you're doing. There's lots of different groups of people who could attack you and make you want to focus in different places. On the internet, we know there are lots of people. If your cluster is on the internet, and it probably is, I think there's 1.7 million Kubernetes clusters currently exposed to the internet, last time I looked. So there's lots of clusters out there. You have to worry about people on the internet trying to break in. And we know that attackers understand Kubernetes and can attack it. There was actually a good example, Datadog have a security research team, and they had a campaign they found just a couple of weeks ago where the attacker was trying to exploit both the Docker API, if they could get to it, and the kubelet API, which I was really surprised about because the kubelet API is not as well known about. And these attackers were actually trying to exploit the kubelet API to do lateral movement. So we know attackers want to take out Kubernetes clusters. So if you're on the internet, you have to worry about that. But you also, say for the sake of argument, you're doing something high value. Say you are a bank, or you are a cryptocurrency exchange is a good example, because those are really good targets for attackers. Financial attackers, people who want to make money from your system. If you're doing those kind of things, there are people who will turn up and they will focus on you. They won't just scan the whole internet looking for people to attack. They'll try and take you out. The thing about them is the effort they put in tends to depend on how much money you have. If you're a huge organization doing billions of dollars of transactions or billions of euros, you'll get a lot of them. If you're a small company, probably not so much. Another group. What about ideologically motivated attackers? I think everyone has seen now that there's lots of those. If your organization is doing something that other groups don't like, or you're doing something related to the government. There was the example this morning from one of the talks where they were saying they stored all of Italy's identity documents. Well, if I'm a country or a group who doesn't like Italy for whatever reason, I might target them because they're related to the nation state. And that kind of attacker is interesting because they'll spend a lot of effort no matter how big a company you are. Small charities, for example, might attract the attention of very well-funded groups. Different set of attackers, different set of things you need to worry about. And then there's two more groups, and there's two groups that people don't think of as attacker groups or places they might force them to spend their resources. First one is insiders. We don't like to think about insider attack because you don't like to think that someone you work with might do something they shouldn't, with the access you've given them. But criminal cases will say, actually, that's not true. And the other one is, I noticed it was last week, an American research company called Mandiant noted that a whole lot of US tech companies had hired people who said they were from one country and said they were one person, and in actuality were from a hostile state trying to get information out of those companies. And they basically went through the whole onboarding process, became staff members, and had internal access. So they're attackers. And if you have that kind of person in your environment, you've got a different set of problems. And then the last one isn't really a threat, but it's where it might dictate where you spend your resources, and that's compliance. Processing personal data, you have to worry about GDPR. Processing cardholder data, you have to worry about PCI. And those might dictate that you have to spend your precious special resources in ways you wouldn't want to, because compliance is binary, right? It says you do the thing or you don't do the thing. And even if it's not the best thing to do for security, you're still doing it. So those are all things to consider. And the last one to think about is, where might they attack you? Where could I be attacked? And this comes down to thinking about, so if you're going through this process, thinking about this, go back to those models of how I'm using Kubernetes. Imagine you had one of those clusters that had no internet access. Well, then you don't probably need to worry too much about internet-based attackers. So none of the apps, say all the apps are internal processed. That's not part of your attack surface because they can't get to you easily. But you have to worry about probably internet attackers. So if you're on any cloud-managed Kubernetes, so I'm guessing people who use either AKS, EKS, or GKE, can I get a little show of hands? Cloud-managed Kubernetes, quite a lot. The default for those is to put the API server on the internet. So your API server will be on the internet unless you've turned it off. It's generally my first piece of thing I always say to people who run those is, if you don't need it, please do turn it off, because it means you're exposed. That's your attack surface, is your API server. You make a misconfiguration, someone gets a set of stolen credentials, bad times. You might have to worry about compromised containers. If you have one of those big clusters with 1,000 apps, statistically, one of them will be vulnerable. Someone will break into one of the applications. What can they do when they get a container? And then lastly, maybe you have to worry about insiders and those kind of attacks. At that point, that's in your attack surface. So all of those things is really to say there are lots of places that people might try and break into your clusters, but you need to give some thought to which of those applies. So when I say it depends, which is kind of what I've been talking about so far in this talk, these are all the reasons why it depends, or some of them anyway, some of the main ones. So when you're thinking about essentially what I would call threat modeling your clusters, think about what type of Kubernetes am I using? Think about who do I think might try and attack me? You won't know that all of the time, but for example, internet-based attackers, you know they're there, so you do have to worry about that. You might need to worry about internal insiders, kind of depends. And then attack surface, where can they attack me? Those are the questions. So now we've kind of covered off those questions and kind of some of the things that people might try and do. What are some of the main considerations that you need to take into account in actually what choices can you make? Right? So you've come up with this idea of who might attack me and where, but what can I do about it? What can I actually change? First thing is, probably for me, is what distribution am I going to use? So are you going to use managed Kubernetes? We've seen by show of hands, quite a lot of people do. I always think of managed Kubernetes like eating in a restaurant. And the reason for that is you have a menu of choices, right? So when you install a cluster in the cloud using managed Kubernetes, you get a menu of options. These are things you can choose. And you don't need to worry about, in a restaurant, to use the restaurant analogy, you don't need to worry about how the kitchen is set up. You don't need to worry about the chefs that have been hired. You don't need to worry about buying the ingredients or cooking the ingredients. All you need to know is what's on the menu. So that sounds great, right? We said we have limited resources. We don't have money to do everything. We don't have to worry about this anymore. Sounds fantastic, right? That's a security win. And the answer is possibly, but there are some things to think about, which is, what if something you need is not on the menu? At that point, you might be stuck. So to give a kind of concrete analogy, because that's a bit abstract, one example I did, I looked around some of the managed Kubernetes. There are lots of managed Kubernetes service, obviously. It's not just the big three. There are many of them. I think actually some of them have got booths outside. So there's lots of different ways to have managed Kubernetes. They don't all have the same facilities. A good example was Kubernetes audit logs. So hopefully people know and use Kubernetes audit logs. There are some managed Kubernetes services that don't have that as an option. As in, you can't turn on audit logs, you can't configure them, and you can't even turn them on at all. So if you imagine, say, you have a compliance requirement, right, your PCI, and your auditor comes along and says to you, show me evidence of who's accessed what over the last 6 months. And you say, of course, I'll do that. You go look at your cluster, and you find out you've got no audit logs. Not only do you not have any audit logs, but you can't turn them on. So thinking about what you need and what the managed provider actually gives you is important. Another point that I kind of picked up from one of the earlier talks today was saying about how the clouds are not the same. That is very true in my experience with security. Even the three main managed distributions are they have lots of differences, right? In terms of the defaults they choose, the security defaults they use, in terms of the facilities they enable, some of them are different. So it's not a question of one size fits all. Again, it's very much dependent. But that's great, and that's obviously, if asked, and I said the majority of people, what should you do? Managed Kubernetes probably still makes sense, because lots of things you have to worry about. But you might want to do unmanaged Kubernetes. To stretch the analogy, if I'm going to stretch the analogy, the cooking analogy, this is like having your own kitchen. You either employ private chefs, or you do it yourself. The great thing about that is you get exactly what you want. You get to dictate the ingredients, the temperature they're cooked, the kitchen they're cooked in, everything. But you don't have to, then you have to worry about that, and you have to pay for it. And if I was making a choice to say, well, talk about those scenarios I looked at, which of those would I say you actually do what in? Vast majority of people use managed Kubernetes. You don't want the pain of managing the control plane yourself. You don't want the pain of monitoring the control plane yourself. It's a lot of work. If, however, I was someone who was doing something very dangerous, like multi-tenancy, or I was concerned seriously about high-end attackers, I would say use unmanaged Kubernetes, because you want the control you've got. You want to be able to audit the control plane. You want to be able to manage everything yourself. That choice, that's how I would split it. Next choice you want to make. How am I going to let all my developers and my application owners have access to my cluster? We've seen several talks today already about developer platforms, IDPs, or PaaS, or GitHops. And do you give people access via that option, so they don't actually touch the API directly, or do you give them direct Kubernetes API access? The answer is, I'll give you a short answer and I'll give you a little bit of background, is don't give them direct access. And the reason I say that, and it sounds a bit odd in a Kubernetes conference to be standing up and saying don't let people anywhere near Kubernetes, is the authentication and authorization model that Kubernetes provides is what I'll call flexible, complicated, and a bit obscure. It's very easy to make a mistake. There are lots of places where you might give someone some level of access and actually you've given them more access than you thought. It's very easy to make mistakes. If you abstract all of that away and provide things like a happy path, a golden path into production with a set of defaults and say, okay, you can deploy an application, we'll handle the actual manifest creation, you won't, then that's going to be the right choice for a lot of people. To an extent, you're moving some of the problems to another place, to your PaaS or to your Git setup. But a good example is Kubernetes RBAC, and we actually got a page we developed for this for SIG security with all the different privilege escalation things we could think of. And there's lots of places where you give out one level of access, and actually what you're doing is giving far more access than you thought. So typically I say avoid that problem. If I bring it back to the examples from earlier though, if you had that very simple cluster where the developers are also the admins of the cluster, at that point you're going to give them direct access because they've already got privileged access. But for the bigger setups, multi-tenancy, multi-teams, GitOps or PaaS would definitely be my recommendation. So next one, network security. We've talked a bit about CNI and networking earlier today. Kubernetes famously has a default of everyone gets access to everything. This is great from an availability and getting things working standpoint. It's not great from a security standpoint. Because if I have got lots of applications in my cluster, I don't necessarily want them to be able to talk to each other all the time. If you're running dev applications in the same cluster as production applications, you definitely don't want them to talk to each other all the time. Apart from anything else, it's really easy to make a misconfiguration and have a development front end talk to a production back end by accident. One line configuration problem. So you want to change your network security setup, and you want to set it up in a way that says that is not a problem. So going back to my models from before, the first cluster, single application, single namespace, one cluster, probably fine, just take the defaults. All of the others, you want to do network policy or something like network policy. Two very important things to think about that. First one is you want to block outbound access. So it's not just things coming into the cluster. You want to block access from containers going back out of the cluster. The reason I say that is there's lots of attackers who have worked out that if you deploy in the cloud, you can do things like touch cloud metadata services. And we've seen lots of privilege escalation attacks, right? So an attacker gets access to one container. They then talk to a cloud metadata service, so the 169.254 address, which you may, if you deploy to the cloud, you'll be familiar with it. That address can give you credentials. The credentials in certain clouds can give you a lot of rights. We've actually got a good paper coming out on cloud security soon that'll talk about some of that. But you can get a lot of rights that way, so attackers can escalate their privileges and actually start compromising your cloud as well as your containers. So you do want to block outbound access. You also want to make it default deny. So I've done a lot, over the years, done quite things like firewall development, and it's tempting to try and block the bad things, to say, I know that I don't want them accessed there, but otherwise I don't know what they should access. Don't take that approach if you possibly can avoid it. Always block everything and then say, this is what you can see. The reason for that is it's very hard to know what you can't. So I mentioned cloud metadata services there. I don't know if anyone knows, but in Azure there are multiple cloud metadata services, and they were on different IP addresses. I only found this out fairly recently when I saw a researcher had exploited that fact and got credentials out of one of the other cloud metadata services. Unless you know your clouds really well, you're not going to know all of the places people shouldn't go. So the easiest thing to do is block everything and then allow access as needed. One thing that I see, obviously, I'm sure anyone who manages applications is thinking, that's nice, but how do I know what access should be allowed? I actually think a really exciting development there is open telemetry. If you're using open telemetry or something similar, application telemetry, if you actually look, once you've installed OTel into an application, it will tell you what talks to what, based on real-world traffic. So if I'm designing network policies, that's exactly where I would start. Instrument your application with open telemetry or similar, and then look at the network flows there. It's a great place to start. But do consider this if you're running lots of applications. Next one, obviously, pod security. If you run a Kubernetes cluster out of the box, I'm pretty sure any distribution apart from OpenShift, it's the only one that I think doesn't do this. Anyone who can create pods gets root on the node, on the cluster node. And in a lot of clusters, that ends up being cluster admin. So basically, I can go from create pod to cluster admin, and definitely when I was a pen tester, I used to attack clusters a lot. That was typically the way you'd do it. You could create pod, you got privileged access to the underlying node, then you grabbed whatever credentials were on the underlying node, and you got cluster admin. Obviously, unless you've got, again, that single team example, that's not something you want to happen. But it's the default. So you need to think about pod security. How am I going to stop people getting access they shouldn't? Privileged containers, host path volumes, and there's good documentation of this on Kubernetes site about things like pod security standards and all the stuff there. Gives you a good starting point. So pod security is one that you definitely need to think about, and it's not one, again, it's one that it doesn't come as a default. Kubernetes defaults for security are not great. In most distributions, does depend on the distribution, but in general, you do have work to do. You can't just take it out of the box and run it. And then the last one I would mention is auditing and monitoring. Definitely last, but definitely not least. It's not all about preventative security. One thing, if I learned anything in all my time in security, it's that you can't stop all of the attackers all of the time. Sooner or later, there will be a misconfiguration, a vulnerability, a malicious person who tries to do something they shouldn't, and they will compromise one of your systems, an app, a container, a cluster, a cloud, something. If you don't have auditing and monitoring turned on for security, then you're not going to know what they did, and it makes incident response an absolute nightmare. I don't know if anyone's either been involved in incident response or has colleagues who are in that team or maybe even does that work themselves. The worst thing you can hear in incident response is, we have no logs. Because then you're flying blind, and typically your response is, well, you have to burn the entire environment down and start from scratch because we don't know where the attacker went. From a Kubernetes standpoint, there's a couple of very important points to mention here. First one is Kubernetes audit logs. I do hope everyone in the cluster has Kubernetes audit logging turned on for all their clusters. Right? I won't ask for a show of hands. But I do hope they do. The reason for that is that Kubernetes has a whole lot of things are only recorded in the audit logs. If I ever get, for example, privileged access to a cluster, say for 5 minutes, I can create a backdoor account into the cluster that lasts for years and is pretty undetectable because it looks like a system component. And that works in every distribution apart from EKS and GKE Autopilot. And I can create a backdoor account. That backdoor account will look like a system account, and it lasts for years. And if your API server's on the internet, I can come in over the internet. The only place that there is any persistent record that I did that is in the audit logs. So if you had one of those scenarios, like, for example, the malicious insider, who does that, they go in, they create the account, they walk away, they could come back 6 months later, and you're not going to know they did it unless you had audit logging turned on and you were looking for those actions. So, very important. You also want to be monitoring things like Kubernetes nodes. If you're letting people run untrusted code or you have a lot of applications, you want some kind of agent, and there's lots of good open source examples. There's Tetragon, there is Falco, there are obviously commercial options as well, where you can have node monitoring, but you want that monitoring in place. You want the logs all centralized, i.e. don't keep them with the cluster, because the first thing attackers do when they get onto something is they delete all the logs. So you want those logs kept somewhere central, and you want to retain them long enough to be useful. Don't delete them after a week. because they are still useful. It's not like, performance monitoring or troubleshooting logs, where it's like after a period of time you can say, well, those can go. Audit logs, you need to retain them for a decent length of time, even archive them somewhere so you can get back to them in case you have an incident. But that's definitely one you need to consider as well. So, conclusion. Hopefully, what I have conveyed, definitely the goal of what I tried to convey with this talk, is security is not one size fits all. If you go to a security person and say, is this secure, and they say it depends, they're honestly not trying to be annoying. I know it sounds like it, but it's not true. Think about your threat model. Who do you need to worry about? Who are the people who might attack you? How are you using Kubernetes? Because everyone's different. And think about your threat model and attack surface. And there are lots of choices to make. I mean, it's kind of good and bad. You're not fixed with Kubernetes. You can do so many different things. Choices of CNI, CRI, different providers for all sorts of different tools. But you should need to think about some of those choices and what they mean to you, which ones are actually going to make sense for your environment. And that is me. But just before I stop, if anyone wants to talk about Kubernetes or container security, I'm always happy to have a chat about this. I think we've got a little bit of time for questions. And then also, there's my social links if anyone wants to get in touch afterwards. And I hope that was helpful.
Rory, thank you so much for this talk. It's a great overview, translating all these different aspects and contexts of security into language that non-security people can understand. Now, do you have questions? Yes, please, repeat.
Yeah.
Would you repeat it?
Yeah, so in intruder threats, how often handling razors true? I suppose it depends. Internal threats are a nasty one because you can, there's also there's the predictive aspect. No one likes to think ill of their colleagues, right? But the bigger the team, the more people you allow the access, the more I would be concerned that it's going to happen. So definitely if I had a cluster where I say I had 100 people with kubectl access, I'd start being very worried, not just about malicious insiders, though. It could just be someone loses a set of creds, right? You had them on a laptop, the laptop gets stolen, same effect. But it's definitely something to take into consideration, and that's where things like auditing come in practice a lot as well. So it's hard to say. Like a lot of these things, as someone said to me, people try to quantify security a lot, and they try to say, oh, there's X% of Y happening. No, I don't like those. You just have to realize bigger environments, it will happen sometimes. It's hard to quantify.
Anyone else?
If no one has any questions, I'm going to ask a question.
There's one up there. If you can speak loud.
Oh, I'm afraid that is a stock photo for a cloud class. I'd love to say that was, it's not AI. None of these are AI this time. I'd love to say there was a lovely castle in the cloud you could go and see in Scotland, but I would be lying. There are some lovely castles. There are lots of clouds. Just
I
not
think
that
it's
one.
Neuschwanstein.
You think it's Neuschwanstein?
I think so.
It could be. I don't know who put it together, but yeah. And a stock image site, I'm afraid. I'm going to ask a question and see if anyone knows, because I've got just enough time. Does anyone know what the musical connection between where I'm from, Glasgow, and where we are now is? Anybody? You have to be quite old to know this one, so I'm going to date myself. Right, afterwards, if anyone wants to listen to some good music after this, you want to go and find a track by a band called Ultravox, who the lead singer's from Glasgow, called Vienna, which is a very famous song in the UK in the 1980s, and I've been playing it in my head ever since I got here.
Well, maybe for the people that go to the karaoke, we can ask Liane if we'll play that one. Anyway, Rory, thank you so much for this great talk. Let's have it again for Rory McCune.